Right, so that's cracking. Now for reforming, reforming, as the name suggests, is nothing different than you have your 8 carbon. Is that 8? 1, 2, 3, 4, 5, 6, 7, 8, 9. Well, this is 9. You have your 9 carbon alkane, and you reform it. Basically, you make it into a different alkene. So what I could do is I could draw 1, 2, 3, 4, 5, and then I could put on 1, 2, 3, 4. Now I'm going to highlight the carbons just so you can see that it does contain the same number of carbons, right? So there's a carbon there, one there, one there, one there, 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 there. So, and I'll highlight these over here. If you count, you realize that they both have the same numbers of carbon, same number of carbons, okay? Which means that they pretty much have the same number of carbons. It's just a reformation. It's an isomer really of this nonene. So 1, 2, 3, 4, 5, 6, 7, 8, 9, right? It's a 9 carbon alkane. We broke it up and reformed it, hence reformation or reforming into now 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Oh, that's 10. So I'm missing something then. So I'm going to erase a part of this. Okay, it's supposed to be 9. Oh dear. It's supposed to be 9, but the point is that the point is that it's supposed to be 9. There you go. So here you go. Both of them must have the same number of carbon atoms. 1, 2, 3, 4, 5, 6, 7, 8, 9. Right? So that's reforming. Now we're going to proceed. All right, so the next group of compounds that you want to look at are the alcohols. The alcohols have a functional group of OH, as you can see there, and they are relatively polar. Polar meaning that they have a positive end and a negative end. If something is polar, it means that it is soluble in water, because water is a polar molecule. Okay, so reactions occur where the OH bond is. And again, the first reaction of alcohols, as has been mentioned before, is combustion. Combustion, reaction where you react an organic compound usually with oxygen, all right, to produce carbon dioxide and water, okay? So you produce your carbon dioxide. So I can have C2H5OH plus oxygen to produce carbon dioxide and water. Pretty straightforward. All right, next reaction of alcohols is, and remember now, let me remind you that your examiner wants you to be aware of the organic product. Even if you don't remember the inorganic product, you must remember the product which contains carbon. Okay, now alcohols can react with metals. And notice here we say lower weight alcohols react with reactive metals or active metals to form alkoxides and hydrogen gas. I'm going to show you what we mean by that. So if I have, I'm going to use ethanol here. That's a H, that's a H, H there, H, H, and I react that with sodium. What's going to happen is this sodium is going to replace this hydrogen. Okay, that's all that's going to happen. So you end up with this, O-N-A. Okay, that's what you're going to end up with. Now, where did the hydrogen go? The hydrogen is going to form hydrogen gas. Of course, the equation is not balanced, so you'd have to balance the equation to get the right number of hydrogens on both sides. But you end up with this molecule, which we call sodium ethoxide. Since it contains 2 carbon atoms. Your examiner may not ask you the specific name of the species, but they may ask you to draw the structure. Okay, so remember now, you have your alcohol with your OH there, it's reacting with sodium, and all that happens is the sodium replaces the hydrogen for you to get sodium ethoxide plus hydrogen gas. Okay. Now, next reaction of alcohols is dehydration. As the name suggests here, dehydration is the loss of water. So now let me draw an alcohol and show you And I'm not giving you guys the conditions because at least you should be able to find the conditions for these reactions. Remember, sorry. Remember I said you must know the conditions for the reaction, because when we do some organic questions, so what you'll see is that they will just give you the conditions, the reactant and the product, and you are supposed to know what the conditions are. Or they will give you an unknown reactant, give you the conditions, and you're supposed to figure out what the product is based on the conditions. Okay, so here's an alcohol. I'm using a 3-carbon alcohol this time, right? And all of those are hydrogens. Okay, and I'm gonna just change the color here. You have your hydrogen there and you have OH there. If you remember what I said last week, for those people who are here, when you look at water, you know water as H2O. That's how you know water. That is for inorganic chemistry, okay? When you look at inorganic chemistry, you treat water like this. When you look at organic chemistry, water is viewed as this, HOH. Both of these formulae have 2 hydrogens and 1 oxygen. It's just how you have to look at it so you can understand how to remove your water. So let's remove the water. It's dehydration, so clearly we're going to remove water. And so what you have happening here is this is removed and you end up with an alkene. So we're going to draw carbon, carbon, double bond, carbon. You have a hydrogen there, you have a hydrogen there, and then you have this CH3. I'm not going to write it out. This is CH3. Okay, plus your water, because it's dehydration. So we remove the water from over here, and that double bond forms right here, where the hydrogen between the 2 carbons with the hydrogen and the OH. It can't be formed over here, logically. Can't form over here. Sorry, undo that. It can't form right here because there's no OH over here. So it formed between where the OH and the hydrogen is. Okay, so that is dehydration. Again, I say you need to look at the conditions for these reactions. This paper, you could actually go through it. This is what I tend to give my students. Go through it with your textbook and you write in the reaction conditions. All right. Now, next reactions of alcohols is what we call oxidation. You know oxidation already from 4th form. Usually you know it's being defined as loss of hydrogen, loss of electrons, increase in oxidation state. With organic chemistry, oxidation is not viewed like that. Notice here, usually shows the addition of oxygen. Okay, so when you're looking at oxidation in organic chemistry, look for the movement of oxygen. Okay, not necessarily electrons and those things. Not that it can't happen, but we're just saying it's movement of oxygen and hydrogen mostly. So here's an alcohol. Let's call it this. Let's do this one, COH. Okay. Now, the same oxidants that you guys know from 4th form is the same oxidants that they use in this reaction. Acidified potassium permanganate and acidified sodium dichromate or potassium dichromate. And of course, you know, potassium permanganate changes from purple to colorless, and potassium dichromate or sodium dichromate changes from orange to green. So what happens here now is this. Instead of writing out the reactant, what they tend to do is put a O in square brackets, which means that you have a lot of oxygen. That's what this means, right? This right here means that you have a lot of oxygen, giving that oxygen to the alcohol. So what happens when you give a lot of oxygen to alcohol? Well, you end up, first of all, with what we call an aldehyde. I'll just draw what the thing looks like. The N carbon now becomes C double bond O, and that H is there. And then you have your C, the other carbon there. If you look at the molecules, you'll see clearly what I'm trying to show you here. We're not really concerned about the other product. This is what we want you to focus on. Okay, so this carbon, let me highlight that. This carbon changes into a carbon double bond oxygen. See it right here? And then a hydrogen is attached to that. Okay, so basically, if you look really closely, what you're really removing from this, what you're really removing is these hydrogens. okay? And then this becomes a double bond, like that. That's what happens. So your examiner may ask you to draw this product. However, that's not the final product, okay? So if I give this, if I give the alcohol more oxygen, so here's your arrow again now. So after this species has been formed, I give it more oxygen, right? So that's a lot of more oxygen. So I'm oxidizing it pretty much. What's gonna form is an acid. So I'm gonna end up with, and I'll just draw it right here, C double bond O, O, H, CH3. I'm not gonna draw this part because you should recognize it. Okay, so what you end up with is this ethanoic acid. So really, when you oxidize an alcohol, you first get this thing called an aldehyde, which is this one right here in the middle. And then you move from the aldehyde with further oxidation to an acid. Okay, so this equation, they like to ask you to show the products in a reaction scheme, which you will soon see. All right, so you need to remember this one for sure. Next reaction of alcohols is, I think, the last one. Yes, it is the last one. Esterification, which is the reaction of an alcohol and an acid to form an ester. So we have not done this before. So what I'm going to do, I'm going to draw the acid portion first. This is my acid, C double bond O, OH. And I'm going to use a very simple acid so that we don't complicate things. So I'm just going to put CH3 there. Now, this acid contains 2 carbons. See there, 1, 2, and this is always carbon number 1, so that's 1, and that's 2. So this is ethanoic acid. Now, I'm going to react my ethanoic acid with, let's just do a simple alcohol. We'll do methanol, okay, which is a 1 carbon alcohol. There you go with your methanol. Now, esterification is what we call a condensation reaction. In a condensation reaction, you have 2 products, 2 reactants, sorry, coming together. And when they come together, water is lost. Okay, so when they come together, water is removed. Now, I have in front of you here now 2 reactants. I have an alcohol, an acid over here, and I have an alcohol over here. Now, these 2 things are going to come together to form an ester. It's a condensation reaction. So what's going to happen there now is that water is going to be removed from both of them. Now, if you remember what I have been saying about water, water looks like this, HOH, right? That's what water looks like in organic chemistry, HOH. So you really should be looking for HOH here. And if you look closely, you notice how I orient the molecule that I actually have my HOH. Now you may be thinking, okay, that's H, and that's OH. So I can remove that. That's okay, but it's not correct. All right, so the accurate thing is actually the OH comes from the acid and the H comes from the alcohol. So this is the HOH right there. Okay, so that is going to be removed. Okay, and the product is going to basically be this oxygen. I'm just going to erase that to show you what the product is going to look like. I'm going to erase all of this. There you go. So the product is now going to be this. So you remove the water and this is your product. There you go. It's a long line, but I'm just showing you how the product is formed. Okay. So remember now, right here you had a OH. Let me change that color. Right here, you had a OH. I'm just showing you what was there before. OH was here, and over here you had a H. These 2 things come together and the water is removed. H2O is removed. So this oxygen now binds to this carbon over here. And so you end up with your ester. You can clearly see that this is an ester because it has the C double bond O, O. They're right in the middle of the molecule. Okay, so that's how your ester is formed. Now, a big issue is that you need to be able to name esters. Okay, so you need to know how to name esters. I'm just going to come out of this and go into a whiteboard so we can look at naming esters, because you'd remember that we never looked at naming esters because of the technicalities of them. So let's look at the ester that was just formed. CH3, C double bond O. All right, so this is your ester, and then you have your OCH3 down here. Just remember, that's your ester. Now we want to name this ester. The important thing is, don't know if you'll see this in the textbook, but what I do is I say the acid portion is drawn first, named last in an ester. Acid portion drawn first, named last. So here's your acid portion. It's at the front of the molecule, but we're going to name it last. And your alcohol portion is drawn last, named first. So this portion comes from the alcohol. So that's your alcohol right there. And this is your acid over here. So your acid portion is drawn first, name last. Your alcohol portion is drawn last, name first. So how do we name this now? First thing you need to do is find the number of carbons in the alcohol. You can clearly see that this contains 1 carbon. So you then say, okay, what's the prefix for 1? Meth. So you write meth. And then to that, you're going to add the suffix -il, methyl. Okay, so this portion over here is called methyl. There it is right there. This is the methyl group. Okay, then now you want to name this part over here now. So you count the number of carbons in the acid portion. How many carbons do you see here? 1 right there, and there's 2. So this has 2 carbons. What's the prefix for 2? F. So you say F. And then to that, you're going to add NO8. NO8. So this ester is called methyl ethanoate. All right, and I'm gonna do another one just for you to get what's going on here. So I have here now CH3, CH2, C double bond O, C double bond O, there's a double bond O there, O, CH2, CH3. Okay, so let's see if we can name this species now. Again, remember, this is your acid alcohol portion over here. And over here is your acid portion. Acid portion drawn first, name last. So count the number of carbons in the alcohol. 2. See? 1, 2. So what's the prefix for 2? F. So that's eth. And to that, you're going to add -il, ethyl. Ethyl. Okay. Then now count the number of carbons in the acid portion. 1, 2, and this is a carbon. A lot of students don't recognize that this is a carbon, but it is. So you count the number of carbons in the acid portion. Okay, 1, 2, 3. Prefix for 3 is prop. So you write prop. Okay, and prop, sorry. Then you're going to add the suffix -NO8. So this is ethyl propanoate. There you go. It's not so bad, you know, once you know exactly what you're doing. Right? Count the number of carbons in the alcohol portion, find the prefix, add -il. Count the number of carbons in the acid portion, find the prefix, add -anoate. And that's it for your naming of esters. Okay? So let us get back to that other document now. Word. Okay, so that's how you name your ester. That's how the ester is formed, and that's how we name it. All right, now here are some questions. Give 4 uses of alcohols. Those are things you can find out quite easily. Remember, alcohol is used in alcoholic beverages. They're used for fuels. You may hear about, slipping me, ethanol, which is used in Jamaica as a fuel. It mixed with gasoline. I don't remember the name that they call it right now. But ethanol is used as a fuel. Ethanol is used in alcoholic beverages. So whenever somebody is buying an alcoholic beverage, the alcohol that they're talking about is ethanol. Ethanol is also used to make what? Right. The alcohol in alcoholic beverages is actually ethanol. Ethanol is also used to make, or alcohols are used to make proteins in this reaction. If you remember the dehydration reaction, where is it? In the dehydration reaction, the alcohol was converted into an alkene. Alkenes are used to make polymers. Polymers like plastic bag, black scandal bag. I don't know if you, well, you guys must know black scandal bag, even though plastics have been banned. But black scandal bag, the poly bags, the clear bags that you see season being sold in sometimes, that is polymeric material made from alkenes. Okay, so therefore alcohols can be converted into those things. But of course, you can easily go on Google and say 4 uses of alcohols, and you get that. Now, what is the breathalyzer test? Now, you should know what the breathalyzer test is physically, personally, because none of you should be driving. But the breathalyzer test is what is used to detect if somebody's alcohol, their blood alcohol level is above the legal limit. Now, let me just scroll back up a bit. For this reaction, the oxidation reaction, right? One of the oxidants commonly used is potassium dichromate, K2CR2O7. Okay, acidified potassium dichromate. Acidified potassium dichromate. Now, the situation is this. When the alcohol, remember the alcohol was oxidized, remember the concentrated oxygen. When it is oxidized to an aldehyde and then to an acid, the potassium dichromate is going to change, and you should know this from redox reactions, from orange to green. Okay, that tells me that this person has alcohol in their breath. Now, based on the amount of alcohol, the person, the officer who's checking this person's blood alcohol level would get a reading on a digital scale, which says, hey, this person's blood level is, alcohol level is too high, or it's too low, or whatever the case might, well, not too low. It's never going to be too low, but it's too high. So really, the breathalyzer test is used to detect how much alcohol is in the blood. And what happens is the chemistry behind it is that the alcohol is oxidized by acidified potassium dichromate, and then a color change of orange to green is detected, which is then registered as a number on a digital scale. Okay, so that is your breathalyzer test. And they love to ask about that, so you should be aware as well. Okay. Next question, describe chemically the breathalyzer test. We just did that. The alcohol is oxidized. What is fermentation? Fermentation, if you do biology, you'd be aware of this as well. But fermentation is the anaerobic decomposition of glucose. Now, if you do biology, you'd know that respiration uses oxygen, which we call aerobic respiration. And then without oxygen, it's called anaerobic respiration. So respiration needs sugar, glucose in particular. Now, if it is that I take some glucose and I put it in a container with yeast, right? In a container with yeast, okay? The yeast is going to break down, see it over there. More come. The yeast is going to break down the glucose into ethanol and carbon dioxide. The ethanol may be used no, you can't come down. No. Here's all right, go. Here. You stay over that side. Come. Right. Sorry about that, guys. So what I was saying was that the yeast can anaerobically break down the glucose, right, to form ethanol and carbon dioxide. Specifically in the yeast, there's an enzyme called zymase. Okay, now I can tell you about the conditions for this reaction because you're using yeast, which is a living thing, and you're working with enzyme. Because of that, the temperature can't be above 37 degrees Celsius, which is normal body temperature. If you go above that, the yeast will become, the enzyme zymase will become denatured and inactive, so it will not work. Okay, but the point is, for your purposes, really, you need to know about the zymase, you need to know about the yeast, you need to know that the starting material is glucose over here, and the glucose is converted to ethanol and carbon dioxide. Okay, and the ethanol is the real important part of that. The point, how this was discovered was that winemakers in the past, when they used to put down their grapes, they, after a while, they noticed that the grapes had a certain taste and it had an effect on the body, which then told them that something was happening in the grapes. And what was happening was that yeast was breaking down the sugar in the grapes, forming ethanol. So when they had the grape juice, people got intoxicated. All right. So that's fermentation. And of course, it says down here, now you're supposed to look at fermentation reactions. Describe using equations the fermentation process by which ethanol is produced from carbohydrates such as glucose. We just did that. And we kind of just did the equation. So what, I'll just rewrite the equation a bit here. You have your glucose, which is C6H12O6 in the presence of zymase, right, at about 37 degrees Celsius or less, produces ethanol, which is going to be C2H5OH plus carbon dioxide, which is a gas. Okay, so there you go. That is what your reaction is. And then you can talk about the temperature here if they ask you about that, why the temperature can't be too high or too low. Okay, remember, you can stop me at any point in time to ask me questions. Okay, then now let's see if we can proceed down a little bit further, if there's anything else. Okay, so we are now at acids, reactions of acids. Now, acids have the functional group, which is this. You should know that already. They are relatively polar. I just said polar means that they have a positive end and a negative end. Let me just show you in this molecule how this looks. This is it. This is your acid. This is negative. The hydrogen over here is positive. So this is actually a proton. Okay, just like how you had protons in acids, bases, and salts, and you heard that acids are proton donors, right? That's the proton. Okay, so now that's what your acid looks like. See, positive end, negative end. All right, so now let's look at it now. So we did esterification already, so we don't need to look back at that, right? The next reactions of acids is that they react with metals, right here. Just like how acids reacted with metals previously, it's the same thing here. So I'm going to simplify. Let me not simplify. Oh, wait. So you have your acid here, CH3, C double bond O, OH. And I'm going to react it with sodium because sodium is quite easy and nice. So all that happens again is that the sodium takes the place of the hydrogen. That's it. Okay. The sodium takes the place of the hydrogen, and you end up with CH3, C double bond O, O, Na plus hydrogen gas. Okay. So the sodium replaces the hydrogen, just as what happens with acids, generally speaking. Acids are proton donors. Acids react with metals, and the metal replaces the hydrogen. Okay? And that is what is the same thing here. So let's look at the next one now. Oxides and hydroxides of metals. The definition of this, or this defines a certain thing. Oxides and hydroxides of metals are actually what we call bases. Okay, so see there, the oxides and hydroxides of metals are bases and react with acids to produce salt and water. So let's call this a simple acid now. C double bond O, OH. There's your acid. We're going to react it with sodium hydroxide. Nothing has changed. The metal, sodium, will take the place of the hydrogen, like that. Okay, and so you're going to end up with a product like this, boom, 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 like that. ONA plus water. Okay? So remember now, all you need to do is just remember that the metal is always going to be replacing the hydrogen in the acid, and then you're going to get your respective product, hydrogen gas, or you're going to get water. Okay, same thing down here again. See, acids react with carbonates. Right there, acids react with carbonates and hydrogen carbonates. The reaction yields salt, water, and carbon dioxide. Again, it's the same thing from before. Acids plus carbonate gives you salt, water, and carbon dioxide. It's just that we're now looking at organic acids. And again, the metal replaces the hydrogen. So let's look at this simple acid now. So CH3, notice I'm mixing my formulae. I'm using skeletal sometimes, and other times I'm using the condensed formula or the structural formula. So again, here's your sodium. Your sodium is going to replace that. That's all. And so you'd end up with CH3, C double bond O, O, Na, and it's acid plus carbonate. So you're going to get a salt, water, and carbon dioxide. All right, there you go. That's that, really. Okay, then now let's look at these questions down here. All right, let's look at these things. State 3 uses for acids and give the property for each use. So you can find that out on the internet again. That's not something for us to really go through because it's not really content for you to learn. What are acids used for? You should know one. Vinegar, for example, acid. Vinegar is used in your house all the time. I think cleaning meat and those things. Let's look at the next question. Define condensation reaction. For this now, I will give you a definition, even though you can simply find this on the internet. A condensation reaction occurs when two reactants come together and produce a small molecule, which is usually water. Okay, so two things come together. A comes together with B. A comes together with B, and you get a product AB plus water. It's not always water, but it's 99% of the time water. So you may see some books define condensation as a combination of two reactants or two species to produce a bigger molecule plus water. They just say plus water because water is almost always a product form. Okay, so let us proceed further. Now, esters, we have done esters already. See the functional group of esters they're given, and they are not polar. Now, a popular question that I see a lot is this. They will say to you, okay, John has an ester A. He has an ester A, and he has an acid B, and he has an alcohol C. Describe which of these would be most soluble in water, okay? So now you're thinking, oh my God, what would dissolve in water? Now try to remember, water is polar, and polar things dissolve polar things. So all you're trying to figure out is which one is most polar, the ester, the acid, or the alcohol, okay? Now, of course, it's definitely not the ester. See it right there? They are not very polar. Let me undo that. They are not very polar. Therefore, you should never choose the ester. Right, so your question now is which of the acid or the alcohol is more polar? Now, this is going to be touchy for you because you have not really learned much about these things, and it is not the level for it as yet. So whichever one you say, you can get the mark. You just have to justify it. So if you say that the acid is going to be most polar, then you say, okay, the acid is going to be most polar because this bond right here is polar. So therefore, the acid can dissolve, and you can draw this and show them. And they're like, okay, yeah, you understand what you're talking about. Then you could also say the alcohol. The alcohol has the COH bond, right? And then you say that this is slightly positive and this is slightly negative. So therefore, this is polar, and so it would dissolve in water as well, right? So you need to justify it. You can say whichever answer, but you just need to say why you say that is the case. Critical. That's a critical part of these things. Now, then a question down here says, state 3 uses for esters. You can also find that online, but esters are usually used for perfumes. right? So like when people have perfumes, well, everybody who has perfume, it's really an ester that they have using as their perfume. The perfume may be a mixture, or the ester may be a mixture of different complex compounds, but really it's an ester. Okay, so that's your ester. Now the next thing is we want to define is hydrolysis. Hydrolysis. Now I'm going to draw an ester here in a simple way. Draw an ester. So this is our ester. At double bond O, and like that. This is carbon, CH2, this is CH2, this is CH3. Okay, and this is CH2 and this is CH3. Now, hydrolysis is the breaking down of a molecule using water. So this molecule, this ester was made from an acid and an alcohol. Hydrolysis is the process by which this ester, not just ester, I'm just using the ester as an example, is broken down into what made it up. And what is causing the breaking down is water, hence the word hydrolysis. Lysis means splitting and hydro means water. So water is splitting a molecule. Okay, so when hydrolysis occurs, then the molecule breaks down into the things that make it up in the first place. Okay, this is an ester, so it will break down into an acid and an alcohol. All right, we look more onto hydrolysis when we look at polymers. Now, there are two types of hydrolysis. You have acid hydrolysis and you have base hydrolysis. What do we mean? For both of them require water. But in the acid, you need an acid. So you can use HCl. You finish? You can use HCl. Okay, I'll put it in the garbage for you. You can use acid plus water. You want more? You can use the acid plus water, or you can use a base, which is usually an alkali plus water. So because you use a base or use an acid, we say it is acid hydrolysis or base hydrolysis. Okay. All right. So next thing now is the right equations to show the hydrolysis of ester, any ester using both methods of hydrolysis. Remember, it's just a matter of which one you use, acid or base. And final thing here now is saponification. What is saponification?